Hi students, welcome back to Algebra 1, Day 3. Today we're going to be working on problems that deal with the division properties of exponents with variables. Let's get started with question 1. For question 1 right here, I have x to the 11th power divided by x to the 8th power. Right here we apply the quotient rule, which states that when we have the same base and there's division going on, all we have to do is to subtract the exponents. Right here, it's x to the power of 11 minus 8, which is x to the power of 3. All right, moving on to question 2 here. For question 2, before we rush into applying the quotient rule, we have to first notice that I have a negative base right here, right? So let's find out whether it's positive or negative. Whenever I have a negative base and there's an even power right there, well, I know that it's going to be a positive exponent, right? Because of that even power. So I have a positive a to the 6th power divided by a squared. We apply the quotient rule and we get a to the power of 6 minus 2, which is a to the power of 4. All right, next we move on to question 3 now. Before we apply the quotient rule, we notice that the bases are different here. It's a minus b, and here we have b minus a. No worries, I'm going to make some changes to b minus a. Okay, so let me write out b minus a here. Here are the parentheses and the square, and here is b minus a. Firstly, I'd like to establish that I can change b minus a into a minus b by factoring -1. Okay, so you can see negative a minus b. Whenever I factorize -1 from a parentheses, the terms switch signs. So here positive b becomes negative b, negative a becomes positive a, and I've just swapped the places to make it look the same. Okay, don't forget the red parentheses. Here I'll change them to square brackets here. Oops, let me make sure it's nice and straight. All right, good enough. Okay, now you'll see that I end up with a problem that has a negative base, right? We treat a minus b, that parentheses itself, as the base, and you see that I have a negative base in here. So I have a negative base, and this is to a even power. I still end up with a positive exponent, which means this, at the end of the day, becomes a minus b squared. Now you see something interesting where b minus a squared is just equal to a minus b squared. Right? Meaning it doesn't matter if I just swap the signs of the terms in there, right? So long as I do it equally, where I swap all of them. Now, I'm going to substitute this value into the equation itself, and you'll notice I can apply the quotient rule to get a minus b to the power of 5 minus 2, which is a minus b to the 3rd power. And our solution is A. All right, now I'd like to move on to question 4. Now for question 4, take a look. I have 15 a to the 4th power, b to the 7th power, divided by 5a squared, b to the 6th power. Okay, so since I have division right here, I'm going to write out each division individually. Okay, for each factor of my terms that I'm dividing here. So it's 15 divided by 5, right? And a to the 4th power divided by a to the 2nd power, and b to the 7th power divided by b to the 6th power. Okay, it's less overwhelming if we just split it up and work on it part by part. So here, 15 divided by 5, I know that's 3. And a to the 4th power divided by a to the 2nd power, that's a to the power of 4 minus 2. b to the 7th power divided by b to the 6th power is b to the power of 7 minus 6. All in all, I'm going to get 3a squared b. And that's my answer, 3a squared b. All right, so let me move my solution for question 4, I think, a little closer, so I can write the solutions for question 5. Never mind. I think I should be able to fit it in here. So let's see, I have a minus b to the 5th power divided by b minus a to the 3rd power. And we apply a similar principle that we did in question 3. Okay, but you'll notice here that b minus a to the 3rd power is equal to negative a minus b to the 3rd power. And this is because of the odd exponent that exists there in 3. So it'll actually become negative. So let me write this out. I have, in question 5, I have a minus b to the 5th power divided by a negative a minus b to the 3rd power. All right, so I have positive divided by negative. I'm going to get a negative answer. And this is going to be negative a minus b to the power of 5 minus 3. Well, 5 minus 3 is 2, right? So I get negative a minus b to the 2nd power, okay, or squared. Negative a minus b squared. And it is option D. Okay, once we're all done on this page, let me clear it up and we'll move on to question 6. All right, I'll refill in my answer right here so it doesn't look too weird. Here we go, option D. And we'll move on to question 6 right here. So for question 6, we have a fraction that is being squared. Okay, and whenever that's happening, we square both the numerator and the denominator. Okay, the dividend and the divisor. So let's try it out. Right here, we can imagine this as negative x to the 3rd power being squared divided by 3 squared and being squared again. Now take a look. I have a negative base to the even power, so I'm going to get a positive exponent in the numerator here. And whenever I have the power of a power right here, I simply multiply the powers, or I multiply the exponents. And taking a look in the denominator, same principle. It's the power of a power, so I'm going to multiply the exponents. So here I would have x to the 6th power. And in the denominator, 3 to the 4th power. Okay. 3 to the 4th power is going to be 81. So that's my answer, x to the 6th power over 81. That's for question 6. Now let me take a look at question 7 here. We have a similar principle. So since I have a fraction that is being put to the 4th power, I'm going to do that to the numerator and the denominator as well. So it's x cubed, and now to the 4th power. And this is divided by or over y to the 5th power, and now to the 4th power as well. Okay, let's try this out. Again, we just multiply like we did in the previous question. So it's x to the power of 3 times 4 over y to the power of 5 times 4. And 3 times 4 is going to give us 12. Whoops. I'll draw my fraction bar here. 5 times 4 is going to give us 20. And, well, that's our final answer already. So it's x to the 12th power over y to the 20th power here. All right. Moving on now to question 8. Calculate 64, a to the 5th power, b to the 6th power, divided by -8, a to the 3rd power. All right. So let's try this out. We'll do it part by part here. So let me write 64 divided by -8 times a to the 5th power divided by a to the 3rd power times, well, b to the 6th power. It's not divided by anything here. Okay, so what do we have? 64 divided by -8. Well, we get -8. A to the 5th power divided by a to the 3rd power. So this is a to the power of 5 minus 3. And I have b to the 6th power left. Okay, maybe there's no need for this multiplication sign here. All right, so one last step, 5 minus 3, well, that's 2. So it's -8, a to the power of 2, b to the power of 6. Great. Question 9 now. Calculate 7x to the 6th power, y to the 5th power, divided by 4x to the 3rd power, y to the 2nd power. Okay, same idea here. What I can write is 7 divided by 4 times x to the 6th power divided by x to the 3rd power times y to the 5th power divided by y to the 2nd power. Okay, great. So right here, what I'm going to do is just leave 7 out of 4 as an improper fraction for now. We'll deal with it later. Okay, but I want to work on x to the power of 6 minus 3, applying the quotient rule, and y to the power of 5 minus 2. Okay, again, I'm leaving that improper fraction the way it is, and I'm writing x to the power of 3, y to the power of 3, right, from the subtractions respectively. Now here, it'd be a lot neater if instead of writing an improper fraction as the coefficient of my answer, if I just wrote it in this way, where I write 7x cubed y cubed, and I take this entire thing and divided it by 4, putting the denominator all the way down here. That's just the standard way we would write our solutions. All right, I'm writing the same thing in the answer blank here. Oops, divided by 4. Okay, great. Last question here. Question 10. Okay, taking a look right here, I have a to the 7th power, b to the 3rd power, c to the power of 0, divided by a to the 3rd power, b to the 3rd power. Okay, we do the same ideas here, but before that, recall that anything to the power of 0 is going to be equal to 1. So I can immediately just cross it out because it's equal to 1. So let's write a to the 7th power divided by a to the 3rd power multiplied by b to the 3rd power divided by b to the 3rd power. And wouldn't you look at that? I have b to the 3rd power divided by b to the 3rd power, which is the same number or the same value divided by itself. This is just equal to 1. So again, I can just cross out this entire fraction here and just work on a to the 7th power divided by a to the 3rd power. Here, I'm going to have a to the power of 7 minus 3 which is a to the power of 4. My final answer is a to the 4th power for question 10. All right, so that's all for day 3. I'll see you on day 4. Bye-bye now.